Our third problem demonstrates the common ion effect, and it asks us to calculate the pH of a 0.2 moles of acetic acid solution, given that the Ka of acetic acid is 1.8 times 10 to the negative 8 moles, followed by our reaction. And all the equations we need to solve this problem is the Ka equation and the pH. So first, to start off, we're going to create an ice table just so we have variables to plug in to the Ka equation. So our initial amount of moles for acetic acid we know is 0.2. However, we don't know the initials for our H ion and the acetate, so that would be 0. Next, our change. We see that acetic acid disassociates into hydrogen and acetate, so we will put that, so it loses its moles, be negative x, and these will be gaining them, so we put plus x. Next, we have our equilibrium. So now that we have our variables here, we can go ahead and make an equation for each of them. So acetic acid would look like this, and then we would just bring down the x for the others. So now that we have these, we can plug them into the Ka equation. And this would go something like, so we have our Ka equal to 1.8 times 10 to the negative 5, and that will be equal to x times x, which is just x squared, over 0.20 minus x. Now for our equation, we can go ahead and disregard this x and just read it as x squared over 0.20. So once we solve this, we have x is equal to 1.9 times 10 to the negative 3rd moles, which is also equal to our concentration of H ions. So once we have this, we can go ahead and plug it into our pH equation. So pH is equal to the negative log of, we'll say, x. And our x is equal to 1.9 times 10 to the negative 3rd moles. And once we plug this into our calculators, we have 2.72 pH. And that is the pH of the 0.2 moles of acetic acid.